register initially. Let's connect a switch here to make a circuit breaker. To break the circuit, again I will try to use a resistor here the way I used initially, but in this case what I will do, I'll use a push button to switch this LED on and off. So the switch acts as a circuit breaker. You can use any of the terminal, the left terminal or the right terminal. You can use any of the terminal to connect. So I'll try to connect the top two terminals. I can connect anywhere over the breadboard. So this is the first terminal which is shorted, and this is the second terminal which is shorted. So I don't complete the circuit directly by connecting it to the negative, but I will try to complete the circuit by connecting this cathode to one of the leg of the switch and completing the circuit with this other leg. I can directly connect it here, but I will make it look good. I'll try to connect it here and then I'll try to connect it here. So this is how I have completed my circuit. The current will flow from positive, move through the resistor and then the LED. It will complete the circuit when the switch is pressed. So I am using a switch in the series to this particular circuit. So let's start the simulation and see if our LED works. No, it won't. You know why? Because the switch is not yet pressed. Let's press the switch. The moment I'm pressing the switch, the circuit is getting complete and the LED started glowing. This is how I can use a switch in a circuit. So this is a constant supply from the battery which the LED is getting. This is a DC supply. But what if we want to vary the flow of the current by changing the resistance? So we can directly change the resistance from here. Now this LED is turning on and off, but what if we want to fade this LED? So let's use a potentiometer in our circuit. So what is potentiometer? Let's first understand. So potentiometer is basically a variable resistor. So whenever the resistance is varied, the current across the terminal will get varied. And when the current across the terminal will get varied, the intensity of this LED gets varied. It means you can change the intensity of this LED by just turning the knob from left to right. It means just by changing the value of the resistance. So this potentiometer to have terminal from left to right. Now it is having also three terminals, the terminal 1, wiper and the terminal 2. You can use any of the two terminals, terminal 2 or the wiper, or terminal 1 or the wiper. So in the circuit, instead of using a switch, I'll directly try to connect a potentiometer here. Let's connect a potentiometer. I'll connect a potentiometer anywhere I like, and then I'll try to jump wires so that you can understand easily. Now I'll delete all the circuit here. Okay. Now if you see carefully, the positive terminal is connected towards the positive and is trying to end to the negative. But before that, what I will do, I'll try to connect a potentiometer in between. So let's connect the potentiometer. I'll connect the potentiometer to the cathode, that is a wiper, and complete the circuit by using this terminal 2. I'll complete the circuit by using this terminal 2. So what is happening here is the current is flowing through the resistor and the LED and completing the circuit with the help of this potentiometer. So this pot or the potentiometer is a variable resistance. If I vary the resistance, the current value will change and hence the intensity of this LED will change. So let's start the simulation and see if it works. So if you see carefully, the LED is very dim. So by turning the pot to its higher position, the intensity is increasing. So if you see, the intensity of the LED increased. By reducing the value, it goes down. Yes, so this is how we can change the intensity of a LED using a potentiometer. So let's interface LDR with a motor. So let's drag the motor on the left. So you can directly search it here right by writing motor. You can drag a DC motor here. To make our circuit easier, I'll use a breadboard. I'll use a small breadboard here. And I'll use a LDR, that is light dependent resistor or a photoresistor, which changes the resistance with the light intensity. Now I'll use a power supply that is 9 volt. So I've connected my 9 volt supply to this breadboard. Now I'll try to use and complete the circuit using this photoresistor and this motor. If I directly connect the motor to this battery, the motor will start running, but we won't be able to change the speed. So to change the speed with the light input, let's complete the circuit. So I have this 3 component here: the battery, the motor and the photoresistor. Let's connect the positive to the positive, and to complete the circuit I'll use the photoresistor in series to this motor, connecting it to terminal 1, and the other terminal of the photoresistor will be connected to the ground here. So it's making a closed loop. The current will flow from the positive, make the motor run in reference to the change in current with the photoresistor. So the photoresistor is connected in series to the motor so that we can complete the circuit. Let's start the simulation and see if it works. So it's very slow. The motor is having 6 RPM only. So what is RPM? RPM stands for rotation per minute or revolution per minute. It is also abbreviated as RPM. This is a unit which describes how many times an object completes a cycle in a minute. Let's change the intensity. The moment I'm changing the intensity of this photoresistor, you're able to see the change in the RPM. So the RPM and the current do also have a direct proportionality. Let's change it for more. You can see here, the moment I'm changing the value of the resistance by changing the light intensity, the RPM is getting higher, and the moment I'm getting it down, the RPM is getting lower. Connect the photoresistor in the series to any circuit to change the resistance value. It works similar to the POT, that is potentiometer.